tell us a bit about yourself. Where are you from?
Okay, I am from Russia originally. I went there to Moscow State University.
Moscow State.
Yeah, that's right. Computer science. Then I was founder of one of the startups, very big MySQL and InnoDB in particular users in Russia back in 1999, well before MySQL became so hot as it is these days. Then that stuff got kind of crashed during the bubble, and I went to work for MySQL, kind of a real business stuff.
Do you currently live in the United States, or are you still
Oh
in
yeah,
Russia?
yeah. I've been moving around a lot. I lived in Seattle area, then in London, and then now back here in San Francisco area.
Oh. So, I have to ask the first question. Your specialty is high performance MySQL, and you do consulting.
Yes, indeed.
Okay, so I have to ask the basic question that probably most people who aren't familiar with MySQL would ask is, how does MySQL stack up with Oracle or SQL Server in terms of performance?
Oh, okay. Well, I think MySQL performance is great for what it is designed for. So it's very interesting actually what some people say, okay, well, the MySQL performance is so great for us, and then other would say we tried to move the application from Oracle or Microsoft SQL Server and we don't get adequate performance. The MySQL is not just the different databases, different state of mind from Oracle or even PostgreSQL, and a lot of things you just you've got to do different if you want to get it to perform well.
I see. So if you were starting a project with a very large, say a data warehousing project or a database that really had to scale, you think MySQL would be fine, no worries?
Okay, well, the data warehousing is actually a very specific area where MySQL is not great in many cases. That's why we have a product, for example, as Kickfire showing up, right? Because people are suffering with MySQL. There is like InfoBright, Brighthouse as well. And the challenge here is that the MySQL is not very good in executing advanced, complicated queries, and it also doesn't have any parallel queries abilities out of the box, which are pretty much requirements for any large data warehouse applications.
I see. Okay. So let's talk a little bit about like some details about MySQL.
Sure.
What are the different types of storage engines? In particular, there's InnoDB and MyISAM.
Yes.
Can you talk a little bit about those two storage engines and why one would choose one versus the other?
Okay, absolutely. So, indeed, InnoDB and MyISAM are two of the most commonly used, like mainstream storage engines. There is large amount of storage engines in development these days, but these are not production ready yet, like Falcon, PBXT, Maria. The MyISAM is traditional storage engine, which was very fast for what it is intended for, fast writes, fast reads, compact data storage, but it has limitations like there is no transactions, table locks, meaning it is hard to use it in high concurrency environments.
So it's really probably a storage engine meant for reads.
Yes, but I mean, it is quite usable for many small web applications. Like for example, even the MySQL performance blog, our website, we run into using MyISAM tables because it actually came as default and it just works and we don't bother. Then you go to the larger scale, that is when a lot of problems start to show up, and a lot of them are operational. For example, for a lot of people, they say, okay, we don't really even need transactions with MyISAM, but the table locks are killing us because I'm having this MyISAM table, and wherever I want to run this large query to analyze my data, everything stalls, right? That's bad. Another typical problems people run with MyISAM is fact MyISAM is not crash safe. So your power goes down, and then you have to check and repair your MyISAM tables, which may take long hours, if your tables are large. InnoDB doesn't have those problems. And that is why I think over the years the shift was towards InnoDB, and I would say what InnoDB is #1 production storage engine for MySQL these days.
I see. Interesting. So another question, where do you think MySQL really excels in terms of performance? Does that involve cloud computing? Like, what is MySQL's role in cloud computing?
This is actually an interesting point, because the MySQL really works well with cloud computing. I think you can find that there is a lot of companies out there which run MySQL at massive scale, having hundreds of thousands of MySQL installations. But if you look at that closer, you will see what these people typically have their ad hoc systems, and the MySQL doesn't really provide a lot to be run into a cluster. There is a replication, for example, right? But the rest you have to do yourself. And these days there are a number of efforts going to improve it, like there is MySQL proxy and some extensions for MySQL proxy to allow you to run certain queries on the distributed systems.
How does that differ from load balancing strategies in general?
The load balancing is kind of different. So let's look at the case of load balancing is most commonly used. That's the web servers. You have 50 servers for web servers which are the same, right? All of them can handle requests. And this is easy for web servers because they don't have any data on their own. They talk to databases. Now, when you load balance for the databases, then you have a challenge of everybody has to have the same data, right, to serve your queries. And if you want to write with load balance, and then you've got to replicate your data on this large scale. So these traditional and simplistic load balancing methods, they don't often work so well for MySQL applications. So people often start saying, okay, my application is mostly reads, so why don't I set up one MySQL server and with 10 slaves and load balance my data across the slaves? This works up to a certain point, but then as your application becomes write-bound or as your data size increases, it becomes suboptimal, and you have to chop your data in pieces on what is called shredding the data. And if you look at the big guys like Facebook, LiveJournal, I mean, these are all guys which have some systems to split your data in multiple pieces and work with them in this way.
So they sort of do they break the task up before it hits the database.
Yes, they split the data in smaller chunks, and then most of the queries can be run on the single chunk. Let me clarify it a bit better. For example, you have blogging website, and you can figure out what most of the queries are going to be for given particular users, viewing his posts, his comments, and then nothing really forces you to store all users on the same server. So you can pick many servers and put even users on one and order another.
So there could, for instance, be a web service rule that says anywhere from A to F hit database 1.
Yes, yeah. Well, it wouldn't be the web service rule. It's typically would be implemented in the database access library, or it can be done by MySQL proxy in some cases.
Okay. So another topic that's closely related to that is federation.
Yeah.
Can you explain what that is and how it differs from,
the federation is, I would say, the interesting term which generally applies to their databases, which consist of the different parts. And when you speak about federated databases, that means it's kind of in many pieces, and it also doesn't mean what it's running the same database software. In the general sense, the federation could be like your Oracle database is talking to your Microsoft SQL database to pull up some data for some queries. In the MySQL, when they speak about federation, they probably mean federated storage engine. And federated storage engine is so far more limited. It simply allows for one server to get some data for queries from another server. And it's also relatively limited in MySQL, because when people speak about the federation in some other databases, it's like, it's very complex problem, and it involves outsourcing execution path to a remote server. In MySQL, it's done on the storage engine level, so you have to just, it goes and retrieves data from a remote server, performing all the real execution on the direct MySQL server, which has serious performance implications. So if you are interested how federated storage engine using MySQL queries, it's typically for light duty queries, when you have few rows you want to retrieve from another box or something like that. Well, it's not exactly on the query level. You have to configure MySQL queries or MySQL server properly. From the query standpoint, that would be the normal query, which just talks to the local tables. There is nothing like as in some other systems where you can say, okay, I want to join the table from server A to table on server B. It has to be look like all the tables on one server.
Okay.
Yeah, the distributed transaction is interesting beast. First, it is very interesting to tell what MySQL actually uses distributed transaction, even if you are running single node environment internally. This happens because MySQL has multiple storage engines on its own, and this storage engine has to be synchronized within them, which requires internal distributed transactions to be used. Even if you don't, even if you just say, hey, I'm running in a DB, then anyway you most likely have a binary log which is used for replication and point-in-time recovery, which has to be synchronized with internal state of database, right? And MySQL also supports distributed transaction on the large-scale environments, but if you look at the web world, these are not that frequently used, honestly, because when you get into distributed transactions, especially on the geographically distributed systems, when you run a lot of performance challenges. Well, LAMP stands for Linux, Apache, MySQL, PHP, and I guess now with Sun they prefer the term AMP more, because L should be S, right? And basically that is a stack. The stack of solutions which people use with MySQL. And then I name PHP, actually P stands for everything now from PHP to Perl to Python. And actually Ruby also goes there, even if it doesn't start with P. Query cache is very interesting technology in MySQL. And I think people coming from other databases often mix it with other technologies. The query cache in MySQL actually stores full results for the queries. So whatever complex query was, when you execute the query second time, the results can be retrieved instantly. And worth to note, it really looks nice, but it really applies only to certain websites. For example, smaller websites or websites which are very read-only, because the invalidation for a query cache is very coarse. It's based on the tables. And if you look at any large systems, they would typically perform their own caching methods, often based on memcache instead of MySQL query cache, or in addition to that.
One thing I've noticed is you always say MySQL
Yeah.
or MySQL.
Yes.
Is there a preferred?
This is traditional pronunciation, as I remember said by founders. But I think MySQL is not picky. You can call it MySQL, and you wouldn't offend anybody.
Okay, I was just curious. Okay, well, This is your new book. When did this come out? High Performance MySQL.
Yeah, well, it's High Performance MySQL second edition. That is important because the second edition is, completely rewritten.
Oh, is that right? Okay.
Right, absolutely. So it has like maybe 10% left from the first edition books and written by a very different team of people as well.
Were you on both?
What's that?
Were you on both editions? Did you work?
Oh no, I was only on the second edition. And it came out a few weeks ago, so it's pretty fresh.
Okay. And so there's a lot of new sections. And there's a lot of new sections.
Oh
completely.
yes, yeah, it's new sections, and a lot of sections were revised and updated. What I think is important for a book like that, and why it's kind of getting older, maybe quicker than some other general books, what we want to describe not only what MySQL is great for, but things what MySQL doesn't do well. Okay. Or whatever limitations are, and then MySQL developers read the book or see our complaints in our case, and they fix those, right? So that's a history with the previous book. A lot of things that we mentioned, they were fixed later on.
Okay. Well, thank you very much.
Sure. You're welcome. Thank you.